Hello, ladies and gents. This time we're going to talk about strong versus weak acids and bases. Now, some acids and bases are very, very strong, like sulfuric acid, hydrochloric acid, nitric acid, sodium hydroxide. Those are all strong acids and bases. And some are weak, things like vinegar that we enjoy when we make pickles, and milk that is so tasty and harmless that we put it on cereal and give it to our children. But chemically, what's the difference between a strong acid and a base and a weak acid and a base? In water, acids and bases dissociate, which means they break into ions. And the strength of an acid depends on the number of hydronium ions produced in solution. So you take an acid like hydrochloric acid and you put that in a water solution. It's going to make a certain number of hydroniums, H3O plus hydronium ions. A base, its strength is going to depend on the number of hydroxide ions, OH minuses, that it's going to make in solution. So you take some sort of a base like sodium hydroxide, put it in a water solution, it's going to make hydroxides. And the strength of both of those is going to depend on the number of hydroniums and the number of hydroxides. Now, strong acids and strong bases are compounds that completely turn into ions in solution. So when they go into a water solution, it is a one-way reaction. Some of these chemical reactions, we've had symbols that indicate that they are reversible, but a strong acid and base actually prefer or are chemically more attracted to, electrically more attracted to being ionized than being in a molecule state. Now, through this course, we have used Mickey and Minnie and Donald Duck dancing back and forth, kind of as a visual to indicate what's going on in water solution. You've got ions that are sock hopping around and they're dancing and they're swinging around and they're switching partners. So if we use this analogy for a strong acid and base, that Mickey is dancing with Donald and Mickey is sitting here and he cuts in with Minnie. If you have a strong acid and base, it's a done deal. Mickey and Minnie have found true love and Donald is not getting the girl. A strong acid and base is a situation where once the ions have been created, the reaction is not going to go back and create the original reactant compound. You're not going to give up the love of your life in order to go back into this state that you had before. So, and that has to do with chemical affinity as opposed to true love. Weak acids and bases only slightly dissociate in water solution. Now remember, dissociate means break into ions. Now, if something is a weak acid and base, it produces some ions, but it does not produce all ions. That is not what happens. So a small number of acid in an acid, a small number of hydroniums are produced, and in a weak base, a small number of hydroxides are produced. Let's take a look at a couple of these. If we take phosphoric acid can be found in Coca-Cola. It can also, in a more concentrated form, be used as a cleaner. And when this goes through a reaction with water, the ions are going to bebop around back and forth between being ions and being molecules. Well, there is a preference, and the preference in this state is it prefers to be a molecule. It will produce some, but darn few ions. And because it produces some, but darn few ions, this is going to make it a weak acid and base. Ammonia, cleaning ammonia, actually is a weak base. And ammonia, when it mixes with water, is going to produce some ammonium ions and some hydroxides, but few. And because it only produces few, it is going to prefer, chemically and electrically prefer, being in a molecular form, and that is going to make it a weak acid and base. So back to our Mickey and Minnie dancing analogy. At the dance, instead of Minnie, when she's dancing with Donald and changing partners with Mickey, there is going to be still some swinging back and forth and changing partners, but most of the time she's going to be dancing with Donald Duck. Some of the time she can be bonded in this way and dancing with Mickey, yeah, but this is going to be very little, and this is going to be most of the time. Most of the time is going to be spent in the reactant state. That is the difference. What causes all of this to occur? Electrical affinity, electrical attraction between the individual atoms and molecules. So strong versus weak acids and bases. Weak acid or base is going to produce few ions and stay as molecules. Something like vinegar. You have a vinegar water solution, you're going to have mostly molecules, and a very, very few ions. You have a strong acid or base, going to produce lots of ions. They're going to fully dissociate, which means fully break apart. So a strong acid like hydrochloric acid, you take that HCl, put it in a water solution, you're going to have ions. There is no HCl molecule, there's not a one to be found in the beaker, because they electrically prefer their ionic state than their molecular state. Some of the common strong acids are sulfuric, hydrochloric, and nitric, and we have talked about these. Battery acid, gastric, hydrochloric acid, and nitric acid. A couple of the common weak acids are carbonic and phosphoric from soda pop and Coca-Cola. So those are a couple common weak acids. A couple common strong bases are going to be sodium hydroxide and potassium hydroxide. And then potassium hydroxide can be used sometimes in making soap, not as common as sodium hydroxide. A couple common weak bases are going to be ammonia, found in window cleaner and other common cleaners, and amines. Where have you heard amines? Amino acids, which are building blocks of things like DNA and protein molecules. Now, we've talked about strong versus weak. Let's spend a moment or two talking about concentrated versus dilute. We spent a few weeks talking about solutions, and its solution concentration can be changed for acids and bases. It's typically given in molarity because chemists are the ones who care a lot about acid-base chemistry. It can also be found in percentages. You're going to see that sometimes as well. But it's moles of acid or base per liter of water, and that is that definition of molarity. You can dilute an acid or base down to make it less dangerous. Concentrated sulfuric acid can eat right through cloth or fabric or skin, which is nasty stuff. But you can dilute it down to 6 molar, 3 molar, 1 molar, and even more and more diluted acid, and that can make it less dangerous. Is it still nasty stuff? Well, you've got to dilute it down a lot if you want to make it very safe. Here's another example. Concentrated hydrochloric acid has a molarity of about 12 molar. Concentrated hydrochloric acid with potassium, you mix the two together, you're going to get an instant flame. But you carry around within your stomach about a 0.1 molar solution. This is just a much more diluted version. So there's a difference between strong and weak and concentrated and diluted. You can make any strong acid or base less harmful by diluting it with lots and lots of water. In laboratories, in hospitals, in chemistry labs, in many, many situations, you're going to see safety showers and eye washes. If someone should get a hazardous chemical on themselves, they should wash and wash and wash and wash and wash. And very often they're told to wash for 15 or 20 minutes. And that might seem a ridiculous amount of time, but remember, they're trying to dilute down a very hazardous chemical to the point where it is harmless. And they must do that for a long enough period of time so it is no longer going to harm them. If you should use hydrochloric acid or muriatic acid to clean a driveway or a garage floor, how do you then make it harmless for your environment, your pets, your children, yourself? Well, you must wash with lots and lots of H2O in order to make it safe so it doesn't kill your grass and safe for your family. If there is a big acid or base spill, it will be neutralized with some other chemical, but only after it has been greatly diluted, because that dilution is essential, and then neutralized with an opposite. But professionals are always called in to do what is important. So to kind of summarize this up, strong acids and bases break down completely into ions. Strong acids and bases, weak acids and bases do not break down completely into ions. Concentrated means there are lots of molecules per unit volume, and diluted basically means that they have been watered down with lots and lots of water to make the situation simpler and less concentrated. All right, folks, that will do for this one. See you then. Bye-bye.